So when we're looking at the domain of composite functions, we have to be a bit careful because the domain is going to be the input on this end of the function flow chart. However, the domain here of that initial x can be restricted by the domain of the inside function g, but g has an output that becomes the input of f. So this output, we can also have this input may have a restriction, be restricted into going into the f function, to the outside function. So there's a couple choke points we have to be careful of. So looking at the domain and range of f of x equals square root 25 minus x squared, the domain of that function is restricted. So the domain is going to be, x is going to be in between -5 and +5. Okay, so that's our domain. And the range is going to be, in this case, the range of this function is going to be, well, the minimum it can be is 0, and the maximum it can be is +5. Okay, so we are now looking at g, which is going to get embedded into f. Now, g is a linear function, and g, since it's a linear function, the domain is going to be all real numbers. Okay, so we can write this in the bracket notation as that. This is same as x is all real numbers. And then the range of that function is going to be the same. So the nice thing about this linear function is that the input and output are going to be infinite. So when we look at our flow chart here, as we go through this flow chart, the restriction is not going to be through the g function, but it's going to be what is going to be the restricted in the input of f. So that then we can just look at the domain of the outside function f. So if we want to determine the domain and range of the composite function, this composite function here, the domain then is going to be, well, we can't put in x values that are going to give us values outside of the domain that we can get for our f. So the domain that we can put into f has to match the range of the g function. So we need -5. So the domain is going to be, if I plug in 0, I get the left boundary of that domain. And then I need a domain of +5. Okay, so I got the negative, I'm looking here. The domain of the outside function is going to match that 0. And then the right edge of that domain of +5, I have to figure out the input into the g function. Well, I need a 10 minus 5 to get the +5. So then the domain is going to be 10. So what I can do then is I can put 0 to 10 through the g function. I'm going to get an output of -5 to 5, and that output then matches the domain of the outside function. The range of that outside function is going to be based on just the range of the f of x, which is 0 to 5. So this is using this flow chart and having to keep track of the inside and outsides can be a little bit tricky. And there are some points that we have to be aware of. The restricted points of the input of g and also the input of f is what we have to be considerate of. So we need to also use tables to be able to determine the composite functions. And we've been given the f in a table and the g in a table. And we've been only given certain values, so we can only work out certain values of this composite function. So if we take a look at A, we're first starting with -1. So we're inputting -1 into the g function. What that means then is I'm going to get an output of 5, and that output of 5 then can go into the outside function f. So it goes like that as my flow chart. Once I get the output of 5 as an input of f, the output of that function then ends up being -2. So the value of that is equal to -2. And so you can see there's a flow here from -1 to 5 in the g function. That output of g becomes the input of f, and then we get the output -2. When we look at b, we want the inverse. Inverse of g means that we're going in this direction. Inverse means we're going from, instead of input to output, we're going from output to input. So we're starting with the output value of 5, and we're going to go do the inverse, so we need to find what the input value was. In this case, that's going to be -1. That -1 then is going to be the input value for the outside function f. So then I need to take that value and find it as my input on the f graph, and that's going to give me an output of 3. So that's my answer. So again, notice that the flow of this, because it's an inverse, it's going in the opposite direction from 5 to -1, and we take that -1 and we use that as the input of the outside function f. Looking at C, we're going to start with the f function inside. So we're going to start with the input 5 to get an output of -2. That -2 output then becomes the input value of the outside function g. So there's my -2 value, and then I'm going to apply it through the g function, and I get an output of -1. So there's my answer, -1. So again, notice the flow starts from the inside embedded function, f, and we're inputting 5 into that green function, getting an output. That output goes into the input of the red function, and we end up with the value of -1. For D, we're starting with the g function, but again, it's the inverse, we're starting with the f function. So where the embedded inside function is f, we start with the 0, we get an output of -1. Okay, that -1 output is going to be used as the input of g, but it's going to be the inverse of g. So that's going to go in the opposite direction. So I have to go start from this side, and I'm going to go in this direction. So then the output of the inverse is going to be -2. So again, notice the flow chart. We start with 0, get an output of -1. That output is put backwards to the g function to get a value of -2.